Today we are learning about medians and altitudes in lesson 5.4. Now a median is a segment from a vertex to the midpoint of the opposite side. So like from this example in the picture, from B to F would mean, if this is a median, F is the midpoint of that side. Now, that meeting of all the medians, this point here in the middle, P, where it's multiple median intersecting, or being concurrent, is called the centroid. So centroid again, median, intersection, kind of way to think about it, or the concurrency bit, okay? And what we're going to run into is that we've got this formula here that medians meet at P and AP equals 2/3 of AE, BP equals 2/3 of BF, and CP equals 2/3 of CD. Now again, it's basically saying if they give us any of these three segments, we can solve for the other two. Now I like to simplify it a little bit, right? So instead of dealing with all these fractions, right, that 2/3 of the whole equals, right, that piece, why don't we just kind of multiply here? We got 3BG equals 2BB, right? We cross multiply there. Right, so one more time showing that. Times 3 to both sides, and we get 2BD equals 3BG. So this piece is 2 times some number, this piece is 3 times some number, and what's left? This leftover piece here is one of those, right? It's 1x, right? Because if we've got 2/3 of a piece, 1/3 left, and so this piece is 1x, this piece here is 2x, and the whole is 3x. That works for each median, right? So now if I go to this median, right, this chunk is 2, we're going to call it y because we don't want them all to be the exact same. They're congruent, right? These aren't congruent, right? So that part's going to be 2 times the whole, or sorry, 2/3 of the whole. This one's going to be 1/3 of the whole, and then FC is 3 the whole, right? So the whole made of 3y from median, so the vertex to the centroid is 2 of the y, right? 2/3, and from centroid to the midpoint is y. Okay. That makes a lot of this math a lot easier because then we're just basically solve for y, x, or again we could do the third one and we can call it z. And again, this would be the last one. 2z, 1z, this piece, and then the whole is going to be 3z. Right, so the whole is 3 times some number, vertex to centroid 2 times that same number, centroid to the midpoint 1 of them. Starting off in triangle RST, Q is the centroid, SQ is 8, find the other two values, find QW and SW. So again, you have to assign, is this 2x, x, or 3x, right? From vertex to centroid is 2 of them. So I have 2x is 8, divide by 2, x is 4. Now what does it want? It wants QW and SW. Right? QW is 1x, we know that's 4. 4 plus 8 is 12, or 3 times 4 is 12, right? So those are our answers. We're just basically filling it in using the x, 2x, 3x pattern. Yeah. Next, what about QV? If QV is 5, solve for the other two pieces, RQ and RV. So now QV here, they're saying this one's 5, right? Which value for this segment, this median, which one is that? Now, we already used x, so I'm going to go with y. And that one is 1y. This is 1 because it's from the centroid to the midpoint. So that's 1y, and this other part's 2y. The whole thing is 3 of them. Okay. Now, you'll realize pretty quickly you just need one of the other two segments. And then, because once we find 2y, y is 5, 2 times 5 is 10, 10 plus 5 is 15. Right? I don't really need to go to 3 times 5 is 15. So again, RQ is 2y, we already know y is 5. So 2 times 5 is 10. Next, RV is 3 times Y, or you could just do simply 5 plus 10 right at that point. Okay, so a couple different options there, but we get RV is 15 and RQ is 10. Moving on. There are 3 paths through a triangular part. Each path goes from the midpoint of one edge to the opposite corner. Basically, we have median, right? So we go from one edge to midpoint, one edge to midpoint, one edge, vertex to midpoint. Or I should say opposite vertex. The paths meet at point P. So P is a centroid. If SC is 2100 feet, find the other 2. I'm telling you the whole segment 2100. So it's saying this 2100. Again, 2100 equals what? 2x, 3x, x. Right? This one equals 3x. Divide by 3, we get 700. And now we just need to find out what is PS and what is PC. PS is 1x, PC is 2x. So 1x is 700. And they gave us a label here because it's a word problem, 700 feet. And then 2x, or 2 times 700, they give us 1400 feet. And why do we know that's 2x? Because this is a centroid. Centroid to vertex is 2x. Centroid to midpoint is 1x. One more set. We've got a BT is 1,000 and TC. Find TC and BC. Same situation. So BT is 1,000. Now, hold up, a little different. This one is not inside, it's outside. It requires you to remember the midpoint staging. If you don't remember the midpoint, you're going to be stuck. BT is 1,000, TC is also 1,000, and BC is 2 times 1,000, which is 2,000. Again, you think all these labels are feet. So you got to pay attention, don't automatically start doing 2x, 3x. Next, G is the centroid, find CG and CF. So again, we've done a couple of these. Go ahead, try on your own, see how well you've got it down. See if you match, right? Starting off with the first one, again, labeling x and 2x. X is 10, 2 times 10 is 20, right? 10 plus 20 is 30, right? You also realize that math is kind of a backup there. On the up down here, this one's a 2x. 2x is 18. I color coded this time, even though I used x both times. This one also must be x is 9. 18 plus 9 is 27, and GD was 9. Right? So pretty quick, simple math. Instead of using all the fractions, which the formulas had, you're basically breaking it down to 1x, 2x, and 3x. Next up is altitude. Right, so far we have circumcenter is where perpendicular bisectors are concurrent. Then we have incenters where angle bisectors are concurrent. And we just covered centroids where the medians are concurrent. Next up, we've got altitude is the height of a triangle. Basically, it goes from the base or a line that contains the opposite base, like over here, right, that extend the base. And from there to the vertex, they found the altitude, which I like to call A or H for height. And again, orthocenter is your point of concurrency of altitude. And that's all we're really getting with that one, right? They're not doing anything like a mathematical equation, right? So where all the heights meet, orthocenter, right? Similar to the circumcenter, it might not be inside your triangle. In this picture over here, it's outside. Generally, in an obtuse triangle, it's going to be outside. In a right triangle, it's going to be on the right angle vertex. And in acute, it's going to be inside. Moving on to the next question. The vertices of FGH are 2, 5, 4, 9, and 6, 1. What is the ordered pair of the centroids? So this is combining 5 ones on the proofs in the coordinate system and what we just learned. So there's 2, 5, 4, 9, Move it off on 9, there we go. And then 6, 1. So here's our triangle. Lines aren't perfect, but that's all right. Almost under there. Okay. Okay. I'm making my least straight line. So we've got F, G, and H. Okay. Now remember, how do we find the centroid? Well, we haven't covered that yet, but we know that the centroid is where the medians meet. So reminder, median, just like if you see a median in the car, it's usually in the middle of the road, right? We're looking for midpoint. That's it. So it's a midpoint of G and H, right? So we're going to call this point, we'll find it first. You add the x values, 4 plus 6 divided by 2. Add the y values, 9 plus 1 divided by 2. I'm dealing with these for those who might think I'm making them up. 10 divided by 2 is 5. 10 divided by 2 is 5. So the point 5, 5, right here, there is my midpoint, whatever we'll call it J. So there's one median. Now I'm going to find one more median. I'm going to find the midpoint of this side. So where is F and H in the midpoint? So I'm using the points 2, 5, and 6, 1. Again, adding the x's together, 2 plus 6 divided by 2. Adding the y's together, 5 plus 1 divided by 2. Half of 8 is 4. Half of 6 is 3. So we can call that K. So 4, 3 is my next midpoint. And the median is going to go from opposite side of the midpoint. And where do they intersect? Drawing them nice and neat, they look like they intersect right there. What's that point? 2, 4, 2, 4, 5. So their intersection was 4, 5 of the centroid, right? So that centroid is centroid B. Some might ask, why didn't we find the third one? You only need 2, right? If we go back to the pictures, what if we took out this whole line? Would G still be there? Yes, right? G would still be there. It'd be the intersection of the 2 that are in the picture. So, similarly, right, we only need 2 of these medians to find our intersection point. Find the orthocenter and acute, right, in the obtuse triangle. And again, this is just sketching, so right, we did the height here, and then you might know how to rotate your paper so that that's up top and try to get a good right angle going down here. And one more here, rotate the paper one more time. And it looks like, and this is a guess, because I'm not calculating the height and doing 90-degree angles perfectly, but that one looks to be there. That was the acute. This one's right. Right, if this is right, we've got the height this way, the height this way, and technically the other height would match right here. So it is the vertex. Lastly, the obtuse one, and this is one where you kind of need to extend some of your sides. So again, doing my best I can, there's my height there. Tilting the paper, looking at this way, my height, something like that. And then doing the height this way, pretty close. So that would be my orthocenter, right? My orthocenter would be outside in an obtuse triangle, on the right triangle, and inside my acute. So again, I've said this already, so just a little note. Outside of the obtuse, on the right angle vertex, and inside an acute triangle. Similar to circumcenter, right? Very similar. In an isosceles triangle, perpendicular bisector, angle bisector, median, altitude, from vertex to the base are all same segment. In an equilateral triangle, that is true for the special segment from any of the 3 vertex, right? If I try to find perpendicular here, right, and call that perpendicular, I would find out that it also bisects the angle. I'd also find out that these are congruent, and so on. And it simply comes from short little proof, right? right? We've got angle, side right there already. And all I did was label my side and use the base angles theorem, right angle or congruent. So we may end up proving some of this. So how can we prove? And again, we're gonna take one of those pieces and then prove another. So starting off, plan to prove the median to the base of an isosceles triangle is an altitude. So we're assuming median and we're proving altitude. So again, median means going to go from B to midpoint, giving us congruent sides. How can we prove BD perpendicular? It looks good to me. That doesn't quite work, though, right? We have it labeled reflexive, side, and therefore CP, and it must be perpendicular, right? So not the worst of these options, but that's literally all you would do. So again, writing out plan to prove a little more thoroughly. This may be in your homework, but again, basically if we were given median, it's labeled in there, but I would say by definition of median or midpoint, again, depending on which way you want to go with it. Technically, median tells you we're intersecting at midpoint, but it would tell you AD and BC, or AD and CD are congruent. We already have AB and BC congruent from the given, based on the definition of it being isosceles. And then we would just need that reflexive, right? To give us the third side, and again, what was that? BD congruent to BD. So triangles congruent. We got BAD and BCD. And therefore, BDA and BDC are congruent. Oops, lost my angle sign there. From our CP, and side, I already mentioned. And that's going to say, hey, a linear pair of angles are congruent, so BD perpendicular to AC, and therefore altitude. Right, so that's where it's a little goofy, that ending there. CP, we got the angles congruent if linear pair of congruent angles. Right, so if the linear pair of angles are congruent, then lines are perpendicular. And I would say this last one is just going old school definition of altitude. Right, it's a line perpendicular from the base to a vertex. We're calling something an altitude. So that's kind of how that one looks. That wraps up the lesson. Let me know if you have any questions.